This video I'm going to solve two-sum problem in Rust language. That the two-sum problem is available on LeetCode. All right. So this algorithm that I'm going to follow is I'm going to use a data structure hash map. I'm going to create a hash map and I'm going to iterate over the nums vector which is already present here. And while I'm iterating on that vector, I'll try to find target minus num. Try to find the second number in the hash map. Yes. So if the number already exists, I'll return the vector, and if the number does not exist, I'll make an entry in the hash map. It will get more clear once you watch the code. All right. So here I'll initiate a hash map. In Rust, it's good if you are initiating a data structure with its capacity, so that it will save some time for compiler to try to analyze how much space it must reserve for the data structure that's initiated. This way is faster than just initiating as hash map .new. And because we know that the capacity of hash map won't be exceeding than nums.length, so we can use this type of syntax. And now we will iterate over the vector. Using this syntax in Rust, the nums vectors dot iterator will pass an iterator to the nums vector, and then dot enumerate method will pass two values to us, which is the index value and the number that's with respect to that index. So this is just a way to, it's a syntax in Rust to iterate over a vector, getting it index and value both at the same time. So now I'm going to find here match function is used, and in C++ you use map.find and then value that you want to find, but in Rust you use map, and in C++ you directly get the value if it's already there, and if it's not there then this type returns a null pointer or the map.end. But here in Rust, because Rust try to avoid creating memory errors, the result that has been passed by this function get to us is enclosed in an enum, option enum. So we have to match the enum here. So if we receive a none value, that means if we don't find what we want to find, we'll create a new key value pair in the hash map, which will be num comma index. And if we find the value that we want, sum x is the enum which returns us the value. So by this I mean is if map.get function finds actually exactly the number we get, then the number we want to, then its value is returned as x here. So if we get another number that we want to find, then we will directly create a vector and we will return it here because we found what we want to. And this vector will consist of two indexes of this and x, which is also an index that is returned by the map.get function. And if nothing works, I'll just return an empty vector. All right, let's run the code. I made a few errors here just to make you clear about the Rust data types. All right, so first error that we get. See, so the map function here expected a reference, and the reason why this error occurs is because in Rust is very specific about ownership. So if you're trying to get, suppose it's just an i32, it's an integer, so it's a sort of blittable data type, so it doesn't matter if you send it by reference or not. But suppose if we are sending some data on heap in the get function, then Rust wants that that string must be sent by reference, so that when the call of the thread call comes back here, we actually have the ownership back of that thing. So if we send a string here, we have to send it by reference. So it's just a good practice so that the function get does not take complete ownership of what data type we are trying to send. So here we'll just, the get function will get a reference, and when get function goes out of scope, the reference will be destroyed without destroying the original value that we can access from here. So we have to send it by reference. Let's see. All right, so that error is gone, and now what's happening is we have another error which says expected I32 found U size. So because, as you know, that a vector's index cannot be negative, so this enumerate returns us a U size. U size is like a positive integer. So, and here, as we know, that a vector is returned, and the return vector is type of I32, and I32 can be negative too. So we have to convert this index as I32. In Rust, internal casting is not done, so you have to specifically cast, everything. So here U size cannot be cast, internally cast. The compiler do not cast it for you. You have to cast it in the form of I32, and the way to do that is this. And here we see the another error, and here it says expected I32 found and U size. So even this thing is an I32, so you have to return as I32. You might think that this thing can be negative because it's just no, sorry, I'm sorry. This thing also can't be negative because it's the index that we are storing, and as we can see, index can only be positive. So this was also as an U size, so you have to also cast it as I32. Let's see what the next error is. So here, the compiler asked us to dereferences because, as I told you, Rust is very specific about ownership data. So here also a reference is returned rather than returning a value itself. So when you pass the map function, map.get, what happens is this get function takes this map, which is initiated here in this function, as a reference. And when it actually finds the data that we're trying to find, it returns the reference to that value. So we have to dereference it before we can use it. Let's see. So dereferencing will point us to dereferencing will point us to the value that we actually got. And because we can, and as we know that everything in Rust as defined as immutable if we do not use mute keyword in front of it. So that error was coming because I was not allowed to insert, because I was not making this map, creating this map as mutable. And there you go. We are able to run our code. Let's submit our code. And there you go. You have your solution for the two-sum problem. And because there are not many submissions at this point of time, so the timing and memory usage is very good. But Rust is getting famous slowly. And this syntax just tell you that if nothing happens, just return an empty vector. Yeah, so that's how you solve. Thank you.